Okay, let's go ahead and get started. Hello, everyone. I'm Charlie Smith, Principal Consultant with ESIG. I also serve in a leadership role with the Global Power System Transformation Consortium, or G-PST, whose mission is to bring together key actors across the globe to catalyze a rapid, clean energy transition at unprecedented scale and speed. This is being done by providing a coordinated and holistic approach to the necessary knowledge, education, and support to power system operators across the 5 action pillars. At the core of the G-PST is a large cross-section of system operators from around the world who are dealing with a rapid transition from a system based on synchronous machines to one built around inverter-based resources. The 5 pillars of the consortium include research and peer learning, technical support, workforce development, standardization, and open data and tools. ESIG is the co-lead on Pillar 1, along with Mark O'Malley of Imperial College, and more information on the G-PST can be found at globalpst.org. As the co-lead on Pillar 1, ESIG would like to welcome you to the October monthly webinar of our joint G-PST Pillar 1 ESIG webinar series. This series is an addition to the regular ESIG monthly webinar series and focuses on the G-PST research agenda and associated topics being addressed in Pillar 1. Topics are presented by both system operators as well as members of industry and the research community. An additional series of webinars on the other 4 pillars of the G-PST is also being provided on a monthly basis through NREL. For those of you who would like to learn more about the G-PST and how to engage, please go to globalpst.org and click on the Get Involved tab. Further information on ESIG can be found at esig.energy. Next, I'd like to go over a few logistical matters before we get started. First of all, lines will be muted for the duration of the webinar to avoid unnecessary distractions. For the Q&A, we'll use the Slido platform at slido.com. To ask a question, please navigate to slido.com and enter ESIG10 as the event code. The instructions are also at the bottom of the screen. You'll see a thumbs up button next to the questions on Slido to allow you to cast a vote to help prioritize the questions submitted. We plan to save about 10 minutes for Q&A at the end and then wrap it up at the top of the hour. An email with a link will be provided once the video file has been posted. We also plan to provide short responses to unanswered questions after the webinar, so please don't be afraid to ask your questions through Slido. Today's topic is on a revolutionary approach to the design of the energy control system of the future. As you might imagine, with the changing nature of the resource mix due to the retirement of conventional synchronous machines and their replacement with inverter-based resources, many aspects of system design and operation are going to be changing, and this is just one of them, but a vitally important one as it represents the brain of the system. This is a topic of increasing interest and critical importance to the industry. At a series of G-PST technical meetings in Copenhagen earlier this year, one of the meetings held was the kickoff of the G-PST Control Room of the Future Implementation Council, or CROFIC, under the leadership of 50 Hertz and Energinet. The CROFIC meeting gave a preview of what you are going to hear about today regarding the Modular Control Centre System, or MCCS, and discussed how to speed up related research and innovation. The objective? To bring findings more quickly into operational use and ultimately speed up the energy transition. Today's webinar will introduce the new grid control system being developed by 50 Hertz for the integration of 100% renewables by 2032. It will be presented by Mirko Pracht, Director of Digitalization and System Operations at 50 Hertz, and Program Lead for the MCCS. Mirko will be joined by Arya Fazilat, Advisor for Digitalization of System Operations. Over the past year, I have come to greatly value and appreciate the work they are doing and the leadership they are providing to the industry and to G-PST, and I look forward to hearing what they have to say. Okay, just a short reminder once again to use Slido at slido.com with the event code of ESIG10 to ask your questions. Let's go ahead and get started. Mirko, I will now turn it over to you.
Yes, good afternoon and a very good evening from Germany. Thanks for the invitation and for the introduction, Charlie. It's a very big pleasure for us to present MCCS, the Modular Control Centre System. And we have explored that it's the second time we are presenting MCCS at the G-PST webinar, and we are already thrilled to present you today our achievements of the last year and where we are standing. Arya and myself, we have condensed in the first stage the content of the presentation, and in a way, in a nutshell, we are facing the challenge from a 50 Hertz perspective of integrating more and more renewable energies into the energy system, and we have the target to integrate 100% renewable energies until 2032. And from a digitalization perspective, we are directly in the digital transformation, so that in the future we will have a very strong integration of operational technologies and information technology. And what we want to present you today is our thinking of the modular control center system and the approach to have a central platform for easily data integration and exchange of modules. And by using this T-bone you can see in the middle, to creating a modular approach for all the related SCADA and EMS components which are needed in a control center. And this is not something we are doing in our way isolated. It's something we want to share. And in that way, we are presenting today our results and where we are standing. And we are doing this also in a way with partners in the industry and across the sectors, and by giving also a lot of information on our website, MCCS, gridcontrol.com or mccs.com. This is the very short summary, and now getting into the details. And Arya, who we are, maybe you can start with that. You're mute.
Okay, let's go. For delivering MCCS, who we are, why we are doing it, what it actually means, how and when. So who are we? We are 50 Hertz and Arya, a group of 2 transmission system operators at the heart of Europe. We are sitting now today here in Berlin. We also operate the Belgium grid, and what we do essentially is we plan and build the transmission infrastructure for onshore and offshore. We manage the assets and we operate the system, and we also enable market facilitation. And our strategy is to integrate 100% renewables by 2032. And we do this for supporting climate action, but also to create a more sustainable industry. And that's already the who. So let's go to the why. Integrating 100% of renewable energies in Germany looks a bit like this. So we started with in the year 2000 with 30,000 units of decentralized and flexible renewable energy assets, such as wind, solar PV, and biomass. You see the numbers are increasing very, very fast and very, very strong. So in 2010, we already had almost 1 million units. In 2020, we had almost 3 million units, and we are going higher and higher. And what does that mean for us as a transmission system operator that needs to plan, build, operate, and maintain the on and offshore transmission infrastructure? It means we have to transform everything that we do. We have to build differently. So first of all, we have to scale and be faster and more flexible. So across our value chain, that means for the first part, we need to optimize how we develop and construct transmission infrastructure. More specifically, it means we are building new assets, such as energy islands or the world's first hybrid interconnector between Denmark and Germany. For the asset management, we are going towards predictive maintenance using new technologies such as robots, autonomous drones, and autonomous boats. And for the system operations, we are automating system operations more and more, supporting our colleagues in the control center with a new control center system. And that is the topic of today. We are developing a new modular control center system to be able to operate a grid with very high shares of renewable energy resources. And we also give access to decentralized flexibility by new approaches where we put the consumer at the center, developing new tools such as digital tools such as track and trace. Topic of today is developing the new control center system. And that is the modular control center system. Just so you know, again, that's in a different slide. In 2013, we had 38% renewables in the 50 Hertz network. By 2018, we already at 56%, and we are increasing. Now we are around 72. Actually, in the beginning of this year, in the first quarter, we had 74% of renewable energies in the 50 Hertz network. With that, a lot of challenges are coming, of course. We have more and more decentralized variable energy resources. And Mirko, maybe a question to you. What happened from 2013 to 2018? We went from 38 to 56, and I think we realized that system operation, we cannot use the tools of the past to operate the system of today and tomorrow. Maybe you can.
Yes, and I think with the question of scalability, adaptability, and flexibility, I've already mentioned the key aspects and our journey of learning between this time. And when talking about 2018, 2019, then we are also talking about how to say that the burning time or the burning time of our MCCS, our Modular Control Centre System approach. And maybe some of you are already knowing the this comic picture, which we have created in 2019. And it's a simplified illustration in a way of why we are doing this approach and what does it mean for a transmission system operator. And I want to summarize the key points of the picture, and later on we are going into the detail. And the key aspect is, and this is something you can see on the right side, that the thinking of a modular approach should be that it is possible to, in a kind of plug and play, to integrate new modules and business capabilities, business functionalities into our environment, to supply them with specific data they need. And also in case they are creating new data, which is quite a normal or very important aspect of modules and components in the control center, integrate them into a central message streaming service, and based on that, providing this information also to additional services. And this is a key aspect and the key philosophy of the modular control system approach. And you can also see by the right picture with control and monitoring that we also try to slicing down the functionalities, the capabilities which are in the systems in the control center. So for us, SCADA, supervisory, control, and data acquisition is not one system anymore. We are breaking it down into separated components and modules and starting to reuse functionalities and providing all the necessary data to all of the modules. And this is a big challenge from a TSO perspective because it's a kind of digital transformation, looking into aspects into the architecture of a system in that way, looking into the structure of such modules, and we are not planning or not doing it on our own completely. So it's an approach where we also invite suppliers, vendors, partners in the way of providing modules, and with that, building the baseline or the foundation to have an overall approach by integrating additional modules, and with that, having the scalability, the flexibility, and the adaptability. And with that, we can maybe going into some details about the MCCS platform approach, Arya.
It was the birth hour of the vision with this comic around 2018. And the key of the approach is reusability. And we would like to show you a video. Please indicate if you do not hear the sound. But let's go.
By using a multi-layer platform approach, it is best to start where we and nearly every other TSO are coming from. So what is the status? Operation centers around the world are using SCADA systems to monitor and control the electrical grid. SCADA stands for Supervisory, Control, and Data Acquisition. Typically, SCADA systems provide different functionalities where only the vendor can adapt to new requirements or add new ones. These changes cost a lot of time and money. With our Modular Control Centre System, MCCS, we will change that. We will take a look inside this black box and identify and provide all functionalities that the control centers require and make them available in a modular, open, and reusable manner. We will slice the SCADA system into functional pieces and show how they work together in MCCS. The platform architecture is a layered system. The top layer is the MCCS product line itself. It contains all the different business products such as volt control, forecasting, grid monitoring, grid control, and more. The open design also allows third parties like vendors and partners to create their own products and run them in the MCCS environment. The middle layer is the functional platform called GRASP, Grid, Asset, and System Platform. It contains enabler products such as logging, alarming, time series, data management, and user interface. Enabler products offer base functionalities to other products. The bottom layer is the Elia Group Digital Platform EDP, which provides foundational technologies needed to run functional platforms and business products, infrastructure technology, data and service technology, interaction, and operations and maintenance, O&M. To understand the benefits of this platform approach, we will now take a closer look at volt control. Volt control is using the enabler products time series, data management, and user interface. Let us have a look at forecasting that is also using time series, data management, and user interface. It uses different kind of data, but still the same base functionality. Look at grid monitoring. Here it is the same. We also have the possibility to integrate even more modules or products like alarming. Moreover, we can use the data from the alarming product in the grid monitoring UI. Finally, let us look at grid control, which is using the logging functionality but no alarms. The benefit of the platform approach is evident, reusing functionalities and capabilities across different products, use cases, and customers within the company, but potentially also by other TSOs. The platform approach reduces time to market, money, and resources needed.
Great. And this video, you can also find it on the MCCS website, mccs.com. And that's basically the basis, the fundamental philosophy of MCCS, reusability and modularity.
Should we proceed with the how or the question of the digital transformation?
Yes, let's go. How do we develop this? So we told you about the vision, why we have to develop this modular control center system, but how do we do it? We do it internally and externally. So there are two steps. Internally, Mirko already mentioned, it's part of the digital transformation. As I told you, we have to transform as a transmission system operator across the value chain, from planning, building, operating, and maintaining. For the operation side is we have to digitize system operation. And to do so, we have developed a product organization that delivers reusable and interoperable control center software, so functionalities for the control center. And to do so, we have now 6 product lines of MCCS that are delivering software. These product lines are grid monitoring and control, forecasting, grid analysis, the functional platform itself, and core data, as well as future product developments.
And this organization you can see in the slide is also a fundamental change when talking about the last 2 or 1 year. And given the fact that we need a strong internal basic setup for providing the functionalities of the modules, not only from a development perspective, but also from the operational perspective, because it's very important not only to look onto the question of how we are developing software components and modules, it's also important to look on the question of how we are making sure that we are able to 24/7 having the operational of the system itself. And this is a key achievement of the last weeks and months to establish and completely integrating this environment. And later on, you can also see some of the representatives of the product lines, how they are presenting their components and modules. And this is a very fundamental step. So with that, and I can tell you also from a TSO perspective, this was a very huge achievement and a big change in the organization to integrating a real organizational part, which is representing the different product lines of a software product within the company. And it's a very good foundation also to building the link to additional partners who are contributing to the results of the product line. So it's the starting point for the internal development aspects, but also for the connection and to the link to additional partners who should contribute. And the second element, maybe you can see in this slide by the different colors, the left 3 product lines have a strong focus on directly delivering results which are related to the control center by all the monitoring and control or SCADA related aspects, forecasting and blending data for all the data related and forecasting capabilities we have in the control center, and grid analysis around EMS, load frequency control, and all the stuff. And when going to the right, then that are more and more supporting functionalities. You can imagine for SCADA and EMS components, data are very fundamental and important aspects. And as explained in the video, the functional platform for providing generic overall used components, because reusability is a key, and the future product development for all of the stuff which is in the exploration mode, which we want to explore how to adapt it, how to finding new use cases, or to collaborate and having the starting point for also exchanging with other TSOs and DSOs.
Yeah. To add on this, to build up on this, why do we show you an organigram? We were not a software company before, but now you see the organigram where we actually develop software for the control center system, working closely together with the expert of the control center system. But on this organigram, you see different product lines, 6 product lines, and you see the little dots. So each of these little lines is a product. So each of these lines has a product owner, they have developers, they have an architect, so they develop software. That's their daily job, and that's quite a change also for an institution for us. And all of them have, and you saw it before in the video, but maybe Mirko, you can say a few words on that. And we are preaching this a lot. Reusability and interoperability are key. And maybe you can use the UI interface and the data in terms of reusability, because UX design, user interface, is very important as well for our operators. And this is something we take very serious as well across all different product lines. So we have different product lines with specific products, but also they work together. And maybe 1 or 2 words on the user interface as well, Mirko.
Yes, we have a team with also experts for UI and designing user interfaces which are enabled to be used within a control center for 24/7. And this functionality is created once and then can be completely reused by all of the business modules to ensure that we have the same look and feel, that we make it possible to integrate additional modules and products and components, and providing the functionality to our control center colleagues. And this is one of the key aspects where we are going into this aspect of having this reusability aspect. It's the same quite when looking into additional components like the data management, because you can imagine the data which is ingested from our substations is not only used for monitoring and control, it's even in the same case used in the direction of grid analysis as the foundation for example, a state estimation. And the same story for logging, because all of the components have logging functionalities, even additional components needing logging, and it's provided centrally so that all of the components can use it. And at the end of the day, there is this transversal access to the data by all of the business modules. And this makes it more easy for the colleagues in the control center to work with the environment and give a more harmonized picture and presentation, which is quite important because with the challenges in the energy transition, there are more and more capabilities which are created internally and by the partners. And at the end of the day, they are in a quite seamless presentation to the colleagues in the control center so that they can work with the components and the functionalities in the most efficient way. So reusability is a key. You will hear it quite a lot, and we will also use in the presentations quite a lot, because we are truly living reusability within MCCS. When looking into the picture, then this is what we are doing actually internally, but we already mentioned that we are also collaborating, and maybe Arya can say something about the co-creation.
Yes. So how do we develop MCCS? The first part is product organization, delivering software together with our control center system. But the second part is external, and their co-creation. And there are many examples of cooperation and co-creation. I want to give you a few. One of them is a big success story that we had with our Danish colleagues. So the Danish transmission system operator Energinet is similarly developing software for the control center system. They have a very similar approach, and they're developing an operational foundation. They have the Lego, and we have the T-bone. So for research and development purposes only, and only as a test, we wanted to test the interoperability, the plug-and-play approach, and the reusability. So our Danish colleagues developed a load frequency controller, which we need as transmission system operators. So what we tested in this approach is, can we reuse that software? Or can we plug and play it into our T-bone? And that's something that we have achieved in the beginning of this year, where we used the Danish LFC and we put it into MCCS. We integrated it into MCCS. It ran on the user interface of the Danish LFC, but we connected it with German data, where you saw the frequency and the calculations. And similarly, the other way around, we are doing it with monitoring and control. So this is only for R&D purposes, but it really demonstrates that working together, having an approach, a modular approach, increases speed, efficiency, and flexibility, because we save money, we save resources, and we save a lot of time to develop these functional modules. And just to add on this, we are cooperating with partners across the industry, also with startups, with researchers. And on the 6th of June this year, we had the kickoff, as Charlie said, together with Energinet. We are leading the implementation council of the G-PST on the control room of the future. And the objective of that kickoff was to identify blocking points of accelerating speed from researchers to develop products for the operation. And there we came up with several blocking points that we aim to unblock. And we will launch a research challenge in 2 weeks' time, where we propose an agile environment for researchers to apply to specific research questions. So in 12 months, they can not only write paper, but develop actual modules that we can test in our environment. Because in the past, these researchers did not have access to control center systems and to the architectures and to the data and to the environment and to the experts. So we aim to collaborate with researchers also. Long story short, we aim to collaborate with other TSOs who follow a similar approach, with the whole ecosystem, whether it's researchers, startups, software companies. And by that, we hope to increase the speed, efficiency, and flexibility of system operation, of digitizing system operation. And now we could end this presentation. We showed you many different slides. We showed you who we are. We are a transmission system operator. We want to integrate 100% renewables, and we have a great vision of developing a modular control center system. And you may ask, when are you moving from slides to actually software? But we said already we have a product organization that is delivering actual software. So what we'll do now is we will go live, and live in brackets, because I have to tell you, once a year, we have a special event here in Berlin. It's called the Checkpoint event, where we present our developments. And the Checkpoint event was just 1 month ago, exactly 1 month ago. So as Mirko said before as well, we want to reuse some of that material to demonstrate you what we have developed actually. And we want to, and specifically want to show you a bit about monitoring, a bit about alarming, and a bit about state estimations. So let's start with monitoring and control. That's the product line. And we will now demonstrate to you the product monitoring.
And starting with Christiane, who is leading the the product line monitoring and control, one of the product leads who are managing the software components. So let's go.
Let's go.
So I'm representing grid monitoring and control. And actually, this is the part where you can see and feel MCCS the most, kind of like the tip of the iceberg. You have to have in mind that we deliver mainly 3 tasks. It is providing the grid for the operators. It is making the grid observable and controllable. And with this in mind, Mirko, let's take a look at our geographical navigation.
Yes, for sure.
So this is a map where you can see our control area. And we want to take a closer look at one of our substations. You can navigate through the grid very easily. Mirko, let's find yes and not. So since this is not Geography 101, Mirko has a search function to find it. I can tell you it's located between Berlin and Leipzig. And I said that grid monitoring is one of the key capabilities for grid operations. And we use single line diagrams for this, or kind of like schematic views. Maybe Mirko, you can open it. This is the single line diagram of yes and not. You can see our assets. You can see the assets of the DSO. You can see the topology. You can see the real measurements from the field that are coming in here. And what is new, you can also see the states of the lines and the bus bars. In this case, they're calculated based on the states of the assets themselves. And if a line is green, then it is turned on. And in this case, when you see a red line or red bus bar, it's turned off due to construction. We've shown you SLDs in the past. So this is not a new picture. But we were working immensely on the topic of data quality and getting the quality into this picture, because we have to work on usable use cases, especially for monitoring in operations, and we had a steep learning curve there over the last months. And also we have to make the components adjustable, because this is part of our strategy to commissioning. We have to develop processes and tools to create hundreds of these pictures. And we also
Maybe you can have a short pause, Arya.
But we will talk about
and basically what Christiane is mentioning, this is definitely one of the big learning curves we had in the last weeks and months. She already mentioned that by integrating all the data into the pictures. This is not only by the aspect of having the module components which are visualizing the grid information, and having with Kafka an event streaming bus where we are delivering in topics the specific information for all of the related data you can see in the picture, which is delivered in real time. This is by definition, to be honest, not a big deal. But the challenge is to getting all the data and the configuration extracted from our current environment and from the configuration and the setup of the real physical grid and the substation information, merging it rightly and appropriate together and bringing the data into one aggregated view with all the configuration of the data and all the visualizations. And this is definitely something we have worked and a lot in the last weeks and months, and it's one of the key aspects to making this happen. Not only from a software perspective, but also from the question of bringing the software and the components to life, having the migration stage and making sure and ensure later on that the system can be used for all of the updates, the configuration, and all the maintenance tasks, which are closely related to managing the energy grids, because there are a lot of changes and you need the possibilities within your software components to doing all the stuff and doing all the updates. Let's continue.
about this later. So if you think about the last checkpoint, and Mirko mentioned it briefly, we had a major technical breakthrough when we showed you how we could control the assets from our software in the field. And we controlled the busbar disconnector right here in Neuenhagen. What is new? is that we now can create control commands for all the breakers, all the disconnectors, right here from the user interface. And I think we should try it out.
Yes.
So maybe let's ask Mike, which circuit breaker would you like to control? Okay, yeah, we can do this. So Mirko, in the substation, yes, not 380 kV transmission line, Förderstedt 533 circuit disconnector, no breaker, switch it off.
Okay, thank you for saying that.
It's actually, the dialogue follows a special workflow that the operators use in their day-to-day work. But if Mirko presses this button, I have to warn you, we are in read-only mode right now. So there will be no live switching today because due to development reasons and for security issues, we are not controlling the grid right now from our software, but we get all the real data from the field into the software. So with this click, we actually created the real control command for this asset. And we can open the logbook. It's kind of a very technical back-end view. But there you can see the control commands that were created. And this is one part of the strategy, how we can test these control commands and how we can validate them in the future on our way to commissioning. But to be able to control the grid securely, we do not only have to click buttons, but you have to be able to assess the state of the grid at any time. And this does not mean only looking at measurements and state, but alarming is a very important component as well. So let's welcome Malte.
Okay, so that was on the monitoring and control part.
And the very first impression and our actual status, and we will further develop and increase and scale. Scale is here the really important aspect because from a functionality perspective, we are very close to what we are needing. The key point is the scalability over all of the substation and all the related information. And when talking about alarming, then it's very important because you can imagine for control center colleagues, alarming is one of the key aspects just to make sure that all of the potential events which can happen in the grid and which are related to the digital components can be presented. And what we want to show you is not only that we are able to creating dialogues for the alarming, there is a more interesting part in that. You will see because we have closely linked it to our control center, to our colleagues in the control center of the regional control center. So not only working, reusability is key for the colleagues at the system operations control center, but also working for our colleagues in the regional control center by providing them a more solution which is more enabled for the mobile use. And this is something definitely we want to show you because it's an additional insight of the philosophy, how we are creating the software and by definition also looking and starting into this reusability aspect.
Yeah, the operation of the electrical system doesn't always go smoothly. Besides their day-to-day business, operators need to deal with unexpected situations, such as failing equipment, safety hazards, difficult weather conditions, for example. But how do operators become aware of these unexpected situations? The answer is alarms. Alarms are supposed to serve as early warning systems, alerting operators to any abnormal condition that requires their immediate attention. Effective alarm management is an important tool to prioritize and to respond quickly to such situations, altogether reducing the risk of accidents or major disruptions in the grid. One fact is very important to acknowledge. Operators are humans, and despite their immense expertise, they can only process limited amount of information, limited number of alarms per time, and yes, operators can make mistakes. In the systems today, this is not sufficiently acknowledged. Imagine how sometimes your email inbox feels like, especially after a vacation. So there may be hundreds of messages, most of them are spam, at least irrelevant, but some of them are actually important, and those are the ones you're trying to find. This is a bit how alarm management sometimes feels to operators today. The complexity of the electrical grid is rising. Also, the number of alarms is rising on a daily level, and too many different systems need to be monitored at the same time. This can lead to fatigue and at some point to missed critical alarms. We designed the new system to not only replace the old one, but to significantly improve it. And the colleagues from the control center were an integral part of this. Their experience helped us to find all the pain points in the current system, and together we created the ideas of how to build something much better. So big thank you to all the operators and other experts that dedicated their time. In turn, we can hopefully provide to them a much better system that actually fits their needs. So what is now happening here in the background? Maybe we can have a look at the system as it is today. On the left screen, you actually see our alarm notification center. This is the central place where every alarm appears in a concise manner. The displayed text may be rather cryptic, but operators are trained to work with these well-defined alarms that are used consistently throughout the system. On the right screen, you see our GIS geographical map. And as you can see, for the ones that paid attention, also here, something appeared right now. So this provides additional locational information about the alarms to know exactly where something is important is ongoing. In our case, we seem to have a threatening equipment failure on our transformer 412 in the beloved substation Jessen Nord. Don't worry, these messages are generated on IEC gateway level, so they do appear as actual alarms here in the system, but the real-world assets are actually okay. Einspeisung Drehstrom fehlt means that the transformer has lost its auxiliary power feed-in, a situation to which operators must respond with highest priority. In accordance with the IEC alarm management standard, each message needs to be acknowledged by an operator, in our case, by Mirko, which means that someone is actively working on a solution, be it by direct controls or be it by delegations to other teams. While I was speaking, some further alarms appeared here, now indicating that unfortunately also the cooling system of the same transformer is failing, most likely a consequence of the missing power feed-in. And we're latest now with one alarm that is supposed to come in a second, if Matthias is listening. Yes, now we have the temperature warning, and this means that the transformer is overheating and it will soon be disconnected automatically from the grid. I'm glad that operators have a single list where everything they need to know is in one place. System operation, including the control center, is only the starting point of the journey. The new system will integrate many more company-wide activities, such as grid operation and maintenance and our offshore business. In the end, these business units have to deal with the exact same incidents, just from a different perspective. For example, it's in the end the field worker that takes care of the malfunctioning equipment. Our cloud-based approach ensures that this information is available to anyone at any location, for example, on mobile phone.
And this is the point I already mentioned. You have seen the user interface, which was seen in the normal application, which is used in the control centers. And what you can see here in the picture is the view on the same topic from a mobile phone, and it's the same look and feel. And this is related to the reusability and the aspect that the user interface component is described and integrated in a way that it can be used on different user interfaces for different purposes. And this is a very flexible way to also supporting our colleagues in the field who are working in the regional control center areas with additional information, and with that getting also a very close link between our colleagues in the field and the colleagues in the control center, which in a way is also an improvement from an efficient perspective, and is even helpful to getting the people connected between each other. And these both elements are good examples, the monitoring and control aspect and also the alarming event, which was presented by Malte here, to showing the status and what we have achieved so far by creating the modules and the components, especially for the target of monitoring and control, which is our new SCADA component. Besides of that, and this is something as a kind of small and very short hotspot we want to also present, is not only that we are looking into the SCADA related aspects, we are also looking into the EMS related aspects. One aspect, load frequency control, we have already demonstrated or explained by Arya with our very cool and good collaboration with the colleagues of Energinet. And the second aspect is the state estimation, which is also something we are working on. And this is something we can also present in a live demonstration way by Oscar.
Yes. For Charlie and Ryan, we will be done in 5 minutes. So
important tools, but you can't build a strong house without a solid foundation. We had the analogy already before. And this solid foundation for us are security calculations, like state estimation, load flow calculation, N-1 and short current calculations. These is the bread and butter. This is what the operators need to take good decisions. This goes for here Neuenhagen Control Center as well as for the control center at Arya in Belgium. So how did we approach it to build these complex tools? We took a step-by-step approach similar to optimize and volt control, and we started with a small part of the 50 Hertz grid, CWA1 area, which allowed us to improve the tool while controlling the complexity. But besides good software, there is another key factor for success, and that's trust. You won't sit in a super fancy autonomous car if you don't trust its safety. And we have to build trust for the tools that we develop for the operators. So how do we do that? We build the state estimation and we compare it to the actual running tool. This is these are the results of our state estimation for the CWA1 area. You can see here in the column the estimated values for measurement values, and you can see here the values from the Rechenmodul, from the HEO system, and the differences are actually not very big. So we're actually able, and we've proven that that we can build a state estimation, and the next step now would be to scale it, to make it bigger, to look at the full 50 Hertz grid, and also to connect it to live data. So that's what we will try to do.
And what Oscar was mentioned is a key aspect we have included into our initiative by presenting the components like state estimation, which is a very basic element of EMS. And the key aspect behind this is not only how to calculate a state estimation. The one or the key aspect for us is how to make sure that we are able to providing all the necessary data. And this is just a kind of first proof, because you can imagine within EMS, there are a lot of different security related grid calculations, and providing all of them with appropriate data is something we have to focus on, because data supply for all of the business capabilities within the area of control centers is very important. And with the way of state estimation, we have a kind of starting base, how good we are in providing all the modules with the data. And it's a good element for us to train ourselves and also showing our control center colleagues that this is solvable and that we have a good foundation to providing them for the future components of MCCS, a good approach of having data supply and making and ensuring all the capabilities for the calculations. And with that, we can go into a summary, Arya.
Yeah, let's go to the summary, and we have some takeaways for you, and then we can go into the Q&A. Let's summarize. Yes. So we are a transmission system operator in the heart of Europe, in Berlin, Brussels, and in Europe, and we want to integrate 100% renewables by 2032. We cannot do this with the tools of yesterday. We need to undergo a digital transformation in planning, building, operating, and maintaining the on and offshore transmission infrastructure. For the operation part, this means we are building a modular control center system with different modules, monitoring, control, load frequency services, and etc. It's a central platform for data integration and exchange of modules. And we don't do this alone. We do this together with partners from across the energy sector, but also from other industries and with researchers and startups. And if you want, you can reach out to us on www.mccs.com or scan the code. And the 3 takeaways of today from MCCS are that it is software, not slides. We told you in 2018 we started this initiative, and we now have product organization with 6 product lines. On the photo on one, you see our forecasting modules in our control center. So this screen is showing the forecasting that we have developed in the product line forecasting. We put a screen into the control center, and it's running there for use of our in pre-commissioning with our control center colleagues. Second, modularity is key, not a monolith. We are not building a monolith. This means we use reusable components. This is the basis for efficiency, flexibility, and speed. And we have shown you the example, the successful example of what we can do with that on the basis of LFC with our Danish colleague. And lastly, co-creation, not logins. We really believe in cooperation, co-creation, and we also believe that research is key. And we will launch a research challenge to address the blocking points of researchers, so that researchers also have the opportunity to develop modules for control center systems and go into operation. These are our 3 takeaways. And if you are also digitizing, let's work together, reach out and scan the code or reach out via the MCCS website. We like to learn from you, we like to exchange with you, and we like to work with you. And with that, I give over to Ryan and Charlie for the Q&A.
Thank you, Arya. That was quite a whirlwind tour through the MCCS. I thank you for that. So I had a chance to take a look through the questions that have been coming in on Slido. There's an excellent bunch of questions. They're great. There's some that have some things in common. One of them is open source, and some questions dealing with, are you using open source? Have you thought about open source? What are you doing about the support of the software? How do you envision that occurring? So can you say a few words about the possible role of open source and how you plan to support the software and how it might be made available?
Yes, we can. So basically, we having partly integration of software components which are available on open source base. One of them I already mentioned. We are integrating the message streaming by Kafka, which is one of the Apache org initiatives. And basically, we are in the elaboration and on the evaluation of can it be possible to providing MCCS in an open source way. This is one of the parts we are actually working on, in which way this can be possible. And what are the planning steps for that? But we need some time to elaborate and finalize this point, but it's definitely on the page and on the discussions. And secondly, what you have seen with the perspective of the structure of the product lines, it's a holistic approach to make sure that we are not only simply creating software, but that it is also possible for case of identifying bugs or issues or needing further and additional improvements to enable the kind of support and incident management and to be available for bug correction or implementation of changes.
To add on this, we take open source the discussion on very serious, and next week actually TSOs from across Europe are here in Berlin to discuss open source on different topics such as regulatory, IT security, different topics on open source. So this is a topic that is being discussed internally with all other TSOs as well.
Okay, let me follow up with a related question from the list there, Arya. To achieve what you just mentioned, do you publish APIs, data models, interfaces, etc.?
This is also on the list, given the fact that when we are going into partnerships and when we wanna invite also additional people and companies and entities from the market, then this is quite clear that we need some kind of description of the definition and the interfaces. We are in the first exploration on that. Also, all of the elements we have done in the past were a baseline to elaborate on that, and it will be one of the parts we will go into, just to make sure that the interfaces are quite clear and that there are some definitions how to handling the interfaces. It's important to describe them quite well and having a good definition behind. And this is something we are actually working on and will be also quite closely related to the question we have addressed with open source being finalized and then be available for any kind of partnership we want to look into.
Okay. There's some related questions to open source dealing with cybersecurity. For example, some are skeptical of an open architecture or open API due to cybersecurity concerns or the lack of understanding thereof. How do you dispel such concerns?
Yes, this is something which is in a way, or let me explain it in this direction. We are taking all the aspects around cybersecurity very serious. And what is a key aspect for us is that scanning for cybersecurity issues is a one and a central part. And we strongly believe that it is even better to have it available, and that open source are also providing the possibility to having additional people who look into the topic of finding potential vulnerabilities and being fast in the resolving of them. But basically the key aspect, and this is for all of the components we are working on, because we are completely aware of creating aspects which are related to critical infrastructure, that there are a lot of different scans and improvement steps to ensure that the amount of vulnerabilities is reduced to a minimum, and that we can making sure that we have very robust and resilient software components with additional countermeasures. And by making that available in an open source community, it can even more help to having additional people who are looking on that and helping and supporting that we have a resilient environment. And at the end of the day, and this is maybe the second part we should take into account, that a lot of components which are available on the market more or less mostly include specific software components which are available on the market. And it is I think also a way of going into a strong collaboration by also collaborating in the cybersecurity aspects, which makes it even stronger in the energy community to working on cybersecurity, which is helpful for all of us because it's increasing the resilience of the environment.
Okay, thank you. Here's one that kind of rose to the top, Mirko. What are the differences between traditional SCADA systems and MCCS? Do you have any comparison of those two systems?
Basically, when talking about the differences, then for us, it's a key aspect that we have a kind of different modules which are, in the end of the day, most closely related to the supervisory control and data acquisition. And this slicing down and breaking it into separate modules and components is very helpful, even in the question of being in the architecture and integration of that, because you are thinking more about the aspects of reusability and what of the data you can go and bring into the data acquisition in general, besides the data which is coming from the substations. When talking about monitoring, we not even talk about how we are unable to monitor the typical SCADA or substation related information. So we have also requests to showing information which are related to offshore. And within the group at 50 Hertz, we have an initiative also to providing an offshore operation center, simply by the fact that we have started to modularize the structures about monitoring and control and being more flexible with that, also to using the separated components for additional use cases in the company. And this thinking about the reuse aspects is very important for us. And with that, we are changing a kind of philosophy, not only using the capabilities which are needed for supervisory and control only specifically for control center and system operations, also finding and identifying additional use cases which are applicable to these modules and components. And we believe this makes a strong difference because this reusability aspect is important because it gives us flexibility and speed to also react fast on additional use cases. And this is a key aspect for us in the energy transition.
Okay, I'd like to ask one more question. The question that always comes up about competition with existing vendors. If you get into software development, which goes beyond architecture and API, then you become a direct competitor to vendors. How do you get buy-in from existing vendors?
Basically, the structure of MCCS is organized in a very transparent and open way. I mean, you can see it today. We are talking very openly and transparent about what we are doing and what is our actual status and what we planning for the next weeks and months. And I basically believe that this transparency is helping also to opening the door in collaboration with suppliers and vendors, because we believe that the energy transition can only be happen when we are working very close and collaboratively. And the second part, that we are believing that there is a strong knowledge about very specific functionalities for a specific calculation methods or algorithms which are needed for specific calculations, and that there is fundamental knowledge which can be integrated by the suppliers and vendors. And with that, we are able to create a more or less wider and bigger ecosystem and working collaboratively together. This is one aspect I believe is and can be attractive for the suppliers and vendors, because with that they have a direct opportunity to contribute and to integrate and to provide good solutions into this environment. We, with the base information of the system, can provide good data, and I know from the past that it is a big challenge for suppliers when the TSOs are struggling by providing good data for all of the system and the components, but because of that it's quite hard to integrate them and bringing them fast to commissioning. And we believe that we can also reducing the risk for suppliers and vendors, because the energy transition is a challenge for all of us, and with that also for suppliers. And by having a structure which is more modularized, we can also reducing in the strong collaboration the risk for them, because we can more concentrate on specific components and elements, integrate them, having approved that they are working, going into the next step. And I believe this can be a win-win situation for all of us. And with the focus that we are in collaboration managing the energy transition, this should be the right way forward for all.
Thank you, Mirko. There's certainly a lot to be done, and I think you've made a very strong case that we're much better off working together, collaborating than we were, or than we are working separately. So we're just a little bit past the top of the hour, so we're going to need to wrap it up. I want to thank Mirko and Arya for this really informative webinar on the MCCS. I think it's going to serve as a great source of inspiration for all of us. And as I mentioned earlier, an email will go out once the video file has been posted, and we'll answer the questions we didn't get to and get them posted as quickly as possible. We appreciate your participation, and if you would like to stay engaged, I would like to invite you to participate in the next ESIG webinar on October 16, a global update on GFM projects and specifications given by Julia Matoivasan, the Chief Engineer at ESIG. I'd also like to invite you to have a look at other upcoming webinars, as well as the ESIG Fall Technical Workshop in Providence, Rhode Island during the week of October 21, and there's still time to register. Further information on all of our webinars and events can be found on our website at esig.energy under events, and you're all invited to attend. Information on all the G-PST webinars can also be found at globalpst.org. Mirko and Arya, I want to thank you again for this very timely webinar, and thank all of you for your interest. We look forward to seeing you again in the near future. And in the meantime, everyone, take care, stay safe, and thanks again for your participation. See you soon. Thanks,
Thank you.
guys.
Thanks. Bye.
Bye-bye.
Good night.